Welcome to the video for Chapter 7 that discusses linear search. And linear search is something that has got to be in your toolkit when you do any type of programming. It's a very simple algorithm, but I'm going to show you a bunch of techniques that I use when dealing with linear search. And so the author has a website, and I'm going to put this link to this particular page and to all the animations that he provides. We're going to go through these animations throughout the semester, so I'm going to provide you with that link. And basically what he does is he demonstrates the algorithm and shows you basically how it works. So here we have an array of 10 elements. And I'm going to search for a particular key. The key is the item that you're looking for inside the search. Linear search is going to return the index of where that number can be found inside the array. So let me try 47. You can obviously see 47's in the array. Let's try this. So the idea behind linear search is that you linearly start from the 0th index. You go all the way up to the end, but in the middle, if you find 47, you're done. So obviously 63 is not 47, so we try the next index. 47 is not 42, 57. 47 is equal to 47, so it's found in index 3. That's why it's called linear search. You start from the 0th element, 1st, 2nd, 3rd, all the way up to the end. If you don't find it, okay, like for instance, if I don't find, wrong thing, let's reset it. Let's go ahead and find the number 2. 2 is not in there. And you're going to see search. You're not going to find 2 in any of those elements. Eventually what's going to happen is -1 is returned as a result, because -1 is not a valid index. The index for this particular array is 0 through 9, because there's 10 elements in the array. So -1 is universally the number that's used to indicate that you didn't find something. So with that in mind, let's take a look at some code. Okay, let's take a look at some code, and I have this thing opened already, and let me minimize it. Okay, so what I did was I created a set of methods that people can call and use these methods inside their programs. And this is something that you can do as well. So you can put your favorite method inside a class and give that class a package name. I'm going to call this package Silvestri. And so inside that package Silvestri, I have a method called linear search, or a class called linear search, and I provide a variety of methods. Anything that's public is something that I'm providing the user of this class. So the idea here is I provide a bunch of linear search methods. In fact, I probably should call them, the fact that the class is called linear search, I probably should just call these things search, because you're searching in there. So I'm going to basically call all my linear searches search. Okay, in fact, I think I could do a global search and replace, copy, source, edit, find and replace right there. And I'm going to change all those occurrences to just plain searches. Replace. Let me see where I am now. I think I lost myself. Okay, it won't move. Okay. Replace, where'd it go? Replace. It's not working. Okay, it's just replaced all. Let's try that. All right, I just replaced it all. And so here we go. What's going on here? Oh, that's why. It's the name of the class got changed. Linear search. You got to be a little careful with that. All right, we're good. Anyway, I'm going to provide the user with a bunch of search methods, but you'll notice that this particular search method deals with an array of characters. This one deals with an array of integers, doubles, strings, and I'm going to leave this search method that deals with strings to the side. And we'll talk about that a little bit later. But this is the way you have to do it when you're dealing with Java, because the system will know which of these methods to call by looking at the parameters that you pass it. That's called overloading the method search. Method overloading. But the techniques, what goes behind these searches are all the same. See, here what I'm doing is I'm calling another method called search, and I provide it more methods. So here's what I'm doing. This particular search, I'm not specifying where the start of the search could be and what the end of the search can be. If you don't specify those parameters, then I'm assuming the entire array. Okay, where I pass it the list, I start from index 0, which is what that animation was showing you. I go up to but not including the list.length. That's important to understand. Because if you have an array of 10 elements, list.length is 10, I'm going to be very careful not to include the 10 as part of the search. Alright, because 0 through 9 is what I have to do. And so basically what I'm doing is this method calls another method with more parameters. And then let's take one of these things, like, it doesn't matter if it's character or integer, they look the same. They pretty much look the same. So if I pass it an array of integers, a start and end, and a key, what I do is I check my indices first to see if they're valid. We'll take a look at that in a second. But the array is, the code for the linear search is quite simple. Start the index I at start. If you found what you're looking for, right, list of I, return the ith index. So once you return, you're done. There's no more processing. But if you go from start plus 1, not including end, okay, if you don't find what you're looking for, you're going to exit out to here and you're going to return -1. And you're going to see that each of these methods look the same. Okay, now in terms of checking my indices, you can't start off with a -3 index. That's kind of silly. And in fact, I make sure I put this comment in here that start is the index of the very first number that you want to look at. And end is the index value that's not included in the search. Okay? It's not included in the search. So what I'm going to do is come up with, I use that same method over and over. Whenever possible, you want to use the same method so that you don't reuse code. Always write once and use many times. Okay, so basically, if you take a look at this if statement, if start is less than 0 or greater than or equal to list.length, remember list.length, I don't want to start. I don't want to include that. I call what's called an exception, and we're going to learn about exceptions a little bit later, but the idea is that's a bad piece of data that went into that method. I throw an exception. If you don't handle that exception, you get that classic red gibberish that you see Eclipse display as a result of writing your program. So you want to eliminate that red gibberish. Okay, so I'm going to leave it at that. I will say that you need to know about the string format. And the string.format takes a descriptor, right? And these are the parameters that you want to dump into that descriptor. Now the descriptor will print out bad. Here's a %. That % will try to match up with the parameters you pass it. But this is something really special that I actually encountered relatively recently. I would like this particular % to be matched up with parameter 1. Okay, so it's going to print out parameters, and these are your parameters, 1, 2, 3. So start, bad start index, and see I can reuse parameter 1 again, so that I don't have to put another start parameter there. Okay, I can reuse that parameter 1 everywhere in here. So parameter 1, I'm going to print out. I'm not sure where that pound sign came from. I think I inadvertently typed that in. This guy here is going to print out start equals. It'll print out the bad number and conveniently tell you what the list.length is as well for you to do some debugging. And is a little bit different, and being greater than. Okay, it's okay to include the equal list.length. It's okay to specify that you want to go all the way up from 0 to 10, but you're not going to include the 10. So it's okay to just say greater than. Equal is perfectly okay, because you're going to stop. See, look at this end. Look at where the determination is. You're never going to check the end parameter. So that's okay, and I'm using that same descriptor. See, need to know principle, and just write once. The same descriptor is being used in multiple spots, and with only different data that's being applied to it. So let's take, this is something new too. Search mode. That only really applies when you're dealing with strings. Okay, say I have an array of strings. Do you want to search it case sensitive or case insensitive? Search mode is basically a way for you to specify different values, and those different values are part of this particular piece of data. That data has a data type called search mode. Search mode can only take on these particular values. Now, here's where I'm going to use this. When I'm talking about strings, okay, they only really apply to strings. I have a list of strings, a list of key, and a particular key I'm looking for. If you don't specify any particular way you want to search the string, that means you're going to take that list, search from the 0 to the end for that key, and I want a case insensitive search. Case insensitive. Alright, so basically uppercase and lowercase. Actually, you know what I want to do? I should make it case sensitive. I think I was debugging. I want to make this case sensitive, because if you don't specify anything, I'm going to take a list of strings, I pass it a key, and by default, I'm going to search the entire array case sensitively. Okay? And this calls this method here. This calls this method here. And I provide this method because on the for this method, I want to give the person the ability to go ahead and specify themselves whether it's case insensitive or sensitive. So this sensitive gets passed here for the mode, and I come back up here. Here's the search for strings. It's a little bit more complicated here, but not much. I test for the start and end indices, and I say, hey, listen, is the mode, the very last fourth parameter here, is that equal to search mode.caseSensitive? If it is, that same for loop, that same pattern, but this time you got to use equals. Now remember, you cannot do this with strings. Double equals does not work for strings because double equals applies only to simple data types, primitives as they call it. It does not work with objects. String is an object, so this is not good. Don't do that. Don't ever do that. Okay? So you need to use a method to determine if two strings are the same. This will return true if it's true, and then I return the ith index. Otherwise, I must want to do an case insensitive, and case insensitive requires and ignores equals method. Now, this is still a little bit of duplication of code, but in terms of what we have in our arsenal, this is the best we can do right now. I'm going to show you a way later where you use lambda functions, and you can eliminate one of these for loops. But in all due time. All right. So this is the. Let me save this. That's the linear search. Let's go to our tester. Now I just copied the template. So make sure you put your name and stuff. I changed the name. I changed everything I want. And so let's come over here. Now I made some changes to the linear search. So remember, look, I have to import that linear search from the package Silvestri. Import everything, but the only thing that's in Silvestri right now is linear search. Okay, so that that's because I changed the link. It makes much more sense here. Linear search, you got to specify the name of the class. See, if you don't have the method defined inside the current class you're dealing with, you need to specify where Java can find that that method, and it's found inside linear search, there's no need to have to say linear search, linear search. So I'm going to come down here and just say search. So search. So I have myself an array of 10 numbers, integer array. That's how you specify an array literal right here. And then I got an array of strings, 10 strings of names. Okay, the first thing I'm going to do is test the integer array. This is a nice method that you should get used to. This method here converts the array into a string, and then I'm going to print that string. It puts brackets around all these numbers here. You're going to see that when I run that. So I enter the key. I make sure, I enter a number because that's an integer. I make sure I clear the line. If key is less than 0, stop, because we know for a fact I got to stop this process somehow. We don't want a negative. We want to stop this somehow. I want to try. So if I type in -5, then I'm going to stop the process. That's what I'm doing here. So I search that array for the key. I put that location, the index, in that variable. I print it out. Now I try the string. Now the same thing here needs to be fixed. Change that to search. Linear search.search. It's pretty much the same thing, only this time I'm going to read a key, a string, read a string. Okay, now next line automatically clears the keyboard, so I don't have to explicitly do it like I did here. Reading an integer doesn't clear the keyboard. Reading a whole line does. If I typed in exit, then stop. We're done. Otherwise, I take that key that I typed in, put it into search for that S array, and I print it out. Let's see if this works. Let's run this thing. Okay, here's my key. Let's push it over here a little bit. Integers, testing with integer array. This is that arrays.toString that you get for free out of the JDK. So I'm going to type in the number 22. 22. That key is found in location 2. 0, 1, 2. Yeah, let's try 82. Now, you always have to, when you ever deal with algorithms, you have to look at the extremes to see if they work. 82 is at the extreme. So let's type in 82 to see if it dies at the extreme. Nope, that's the 9th position. And let's try 313. 313 is certainly not in there. Okay, I'm done. I'm bored with this. Okay, now let's try this array. Let's see. Now, by default, you're going to do what's going to happen is if I typed in Ringo, okay, it's not found. It's case sensitive. Case sensitive. A capital Ringo will be found as location 3. Let's try Tim is location 9. Let's see, Bob is not there. Bob is not there. Okay, I'm sick of this already. Exit. Exit. Do we want to do this again? No, I'm bored. Quit this. Okay, let's try case insensitive. And here's what you do for case insensitivity. See, I gave you the ability to provide a search that takes strings and a string key, but there's also a third parameter that I can specify like this. Let's see. I forgot what it's called. Search mode. Huh. Okay, of course. Search mode. So what I'm going to do is say search mode. Let's see. Search mode dot case insensitive. Okay. See, I made this enumeration available as public. I could use it as long as I include. Well, I guess the system automatically made that available for us. Okay, so search mode is now available, and let's see if I can find Ringo with lowercase. Okay, I don't want to do that again. Let's try it. Ringo. Yep, he's location 3. Tim, all capitals. 9. I guess it works. I think I proved to you that this works. Okay, so we'll see you in the next video on Chapter 7 Arrays. Take care.